Welcome back to Rock the JVM, folks. This is Daniel, and you are watching part 3 of the SBT tutorial with Scala. This mini-series aims to help you get the most out of SBT with some essential features that I believe every Scala developer needs to know. Now, this video builds upon the previous project and the previous video that we did in this mini-series. So if you haven't checked that out, I recommend that you do. If you're a seasoned Scala developer, in this video, we're going to discuss some more advanced SBT features. So what I recommend you do is build a standard SBT project with just 2 modules, and then you can carry on from there. In this part, I want to show you resolvers, custom tasks, and then how to do command aliases and a bunch of other features that SBT can support. All right, now, what are resolvers? So resolvers are these locations that SBT can look into when you want to download and install additional libraries, which is obviously a core feature that SBT supports. So I'm going to navigate back to my build SBT, and we have a bunch of stuff here that we filled in previous parts. Now, one important setting that you can set here in build.sbt, much like you can do with library dependencies, is resolvers. So if I do, for example, resolvers plus equals, and then I'm going to use a construct called resolver.url. And resolver.url is a function that takes 2 arguments. One is a name, let's call this my test repository or something like that. So my test repo, and a URL, which is a function that uses some sort of location where you want SBT to search for artifacts, that is for binaries, for libraries that you might want to include. For example, HTTPS or at rockthejvm.com/repository/whatever. So the URL is specified here. And you might see this in other build SBT files for certain libraries where you publish your libraries to Sonatype or to Maven Central or something like that, and you want to add all the resolvers in the same build SBT file so that SBT can search for your artifact everywhere. Now I'm going to comment this one because this URL is invalid, so this is how you can add an external resolver. But you can also add an internal resolver, meaning that SBT will look for artifacts or binaries locally on your computer. For example, you can say add a Maven local repository, where you can say resolvers plus equals resolver dot, and a function is called Maven local. Maven local is a repository that is installed locally whenever you have SBT or Maven or any tool that downloads libraries. And to demonstrate how that works, Maven local is located under your home directory. And if you do ls-la to find out all the hidden repositories or hidden folder here, we have a folder called .m2, which is the place where all the Maven artifacts are stored locally or cached maybe, so that Maven can fetch them automatically. So if you do resolver Maven local here in build.sbt, this is the location on your hard drive where such artifacts will be searched for by SBT. Now, this external resolver part, where you say resolvers plus equals resolver URL, is also a standard practice in many companies where you publish local artifacts just for your company. So when you have your own domain with your own repositories for your artifacts, this is a standard practice to add resolver URL for your internal company's repository. So this quote-unquote external will also work quote-unquote internally for companies as well. All right, so this was how to add resolvers in a build SBT file. Now, I'm going to show you custom tasks. So I'm going to add some comments here, much like we do for other Rock the JVM tutorials where we add nodes in our code. So another powerful feature of SBT is the ability to create custom tasks. So apart from the built-in tasks, we can create some custom ones. And I'm going to create another terminal window here, and I'm going to navigate by my multi-module project. So under desktop, I have a multi-module project that I built in previous parts. And I will go to my project directory where I have my plugins.sbt and a file called constants.scala that I wrote in the previous parts, so that we can refer that code in our build SBT. Now, in this project directory, all Scala applications or all Scala objects or definitions are immediately visible in build.sbt directly without any sort of import. And here I'm going to create, let's call this custom task.scala to demonstrate how you can invoke a custom task in the SBT console of this project. So under the project directory, I'm going to create this plain Scala file. I'm going to create a simple object. I'm going to call this custom task. Let's call this printer because the task is going to be very simple. And I'm going to create a simple method. Let's call this print. So you can name any method in any way that you like. And I'm going to say print line, rock the JVM custom SBT task, for instance. So something like that. A plain Scala file with a plain object with a simple method will do for this demonstration. Okay, so now I have custom task.scala. Now, in build.sbt, I can refer this custom task because all Scala files are immediately available in build.sbt without any sort of import. And in order to create a custom task, I need to define it as a name. So I'm going to define a lazy val. I'm going to call this printer task. And the way that we do that is by using a function called task key. Task key is a function that takes a type argument, which is the return value of a particular task, because tasks can also return values. And I'm going to show you how to do that shortly. And you need to give this a human readable name like custom printer task or something like that. Now, in this case, I've just registered a new task under this name, but I also need to bind this task to the code associated to it. So I'm going to have my printer task. So printer task has this colon equals association or assigner. It's simply a method returned by the object returned by the task key function. And then I'm going to open and close some curly braces, and I'm going to have my custom task printer, which is the name of the object that I created earlier. So custom task printer dot print. So in this way, I'm binding the code to the task object that I've created. So binding code to task. Cool. So after I've done that, after I've defined my printer task, I can write the build SBT file. Then I can invoke the SBT console in this project, which will take a little bit of time. And then after the SBT REPL is loaded, I can invoke this printer task. So I can say printer task exactly as it is. And notice that the printer task's code is being executed. So this may bring some artifacts, this may invoke some plugins, this may invoke some whatever. And the printer task will simply run whatever code I associate to that, which in this case is just printing something. So this is how you can create a custom SBT task, and this can very much improve the power of your build system because this can go as wild as you want. Now, I'm going to create another task that will return a value. So I'm going to kill my SBT console. I'm going to go back to my project directory, and I'm going to add a task that does a little bit differently, which is returning a value. So I'm going to have, let's call this string task.scala or something. I'm going to define an object. So an object, I'm going to call this string task. And I'm going to define a simple method, call this string task, and this returns a string. And I'm going to implement that as uuid dot random uuid dot to string. I don't remember if I need to import anything. I don't think so, because the sort of standard Java/Scala packages are already included, if I remember correctly. Let me go back to my build.sbt. So I'm going to edit that. And I'm going to define a lazy val that will return a task key of string in this case. I'm going to call this lazy val. I'm going to call this uuid string task as a task key of type string. And I'm going to call this random uuid generator. Cool. Now the uuid string task will be bound to my string task dot, I think it's called str task, if I remember correctly. Let's exit that, and I'm going to view this one. So str task, this is the name of the method here. And then I can exit, and then I can try running the SBT console to see if that works. And obviously, as I anticipated, this UUID thing was not important. Let me go back to my string task, and I'm going to import that. UUID, I think it's called, it's imported from Java util. So import Java util UUID. Let's write that, and let's try running the SBT console again. Okay, no hiccups this time. All right, now let me print my UUID string task. So UUID string task. So if I try running this, it just runs a success because it generated the string, but I cannot see that. So we might want to print whatever was generated by this UUID string task by editing my build SBT file and calling the UUID string task from the printer task. So tasks can depend on one another if you're interested in doing that sort of thing. So let me try editing this build SBT file to invoke the UUID string task. So let's call this UUID as UUID string task.value. That's how you can obtain the value returned by running that task. And I can say, for example, print line generated UUID, and I'm going to inject the UUID inside. Obviously, I need to use an S-interpolated string, so I'm going to print that, and then the custom task printer.print, which is invoked from somewhere else. Just to demonstrate that, let's run the SBT console. And after that, we can run the command with printer task. So printer task. So notice that this invoked the UUID, which is the string task, and we have a valid UUID, and we have the rest of the code. Now, if we call printer task multiple times, notice that the UUIDs are different because the generation takes or runs every time we invoke that task. But if we want to memoize whatever UUID we are running at any particular point, we might want to change our code a little bit. So I'm going to edit my build SBT to do that. So if you want to save a custom value, you can do that with a custom setting. So custom settings. And you can define a custom setting much like you do a custom task, and you can define a lazy val. I'm going to call this UUID string setting as, instead of a task key, I'm going to use setting key of type string, and in much the same style, you can pass a name. So I'm going to have random UUID setting. Now, after you've defined the UUID setting as a structure, let's say, you can bind the code associated to the string by saying UUID string setting, and you can use this funky association or assignment operator, and then you can pretty much do the same thing. So I can say UUID string task.value, so I'm going to have val UUID as string task.value, and then you can return that UUID, and you can add some more code, and then you can return a symbol value, which is the string that was generated. All right. Now you can also produce side effects inside. So in this add some more code, you can also print something if you're interested. I'm not going to do that. And inside my printer task, I'm going to show you the difference between invoking the UUID string task and invoking or using the UUID string setting. So let's call this UUID task as UUID string task.value, generated UUID from task. And I'm going to pretty much do the same thing. So I'm going to copy that and paste it twice. So I'm going to have it here. And I'm going to call this UUID, let's call this setting. So I'm going to have my UUID string setting.value. And inside my print, I'm going to have generated UUID from setting. So if I save my build.sbt file, notice that now I'm going to print two UIDs. If I start my SBT console, it'll take a couple of seconds. If I call my printer task, we will see two UIDs generated. So we have value UID. Okay, I forgot something. So let's go back. Generated UID from task, and this is my UID task and UID setting. All right, cool. Let's try that again. And if I call my string task.value, okay, what's happening here? So UID string task.value, this is, no, this is UID string task.value, silly me. And I'm going to save that, do that again. Okay, you know what? Let me edit that in my other terminal. So build SBT. What am I doing here? So we have UID string task.value. The setting cannot depend on a task. And this is a nice error from SBT. It says the setting cannot depend on a task. So I'm going to invoke the code directly. So instead of saying UID string task.value, I'm going to call the string task.str task. So string task, much like we did earlier with the UID string task itself. So notice that essentially I'm having the same code for a setting as for a task. Now the task, as you noticed earlier, is generating a new string every time, whereas the UID string setting, as you will see shortly, will memorize whatever value it generated once. So it's like you define a def that you can invoke multiple times in the SBT console, or a val that you can use all the time with the same value. All right, let's save this and let's try this again. Cool. And now my SBT console is successful. And if I do print task, where's that? Printer task. So printer task. And notice that we have generated UID from task and from setting. Obviously, these two are different, but if I call this multiple times, notice that the UID from task is always different between two runs, but the UID from setting is the same. This is a powerful feature of SBT that it allows you to define custom settings and custom tasks for pretty much arbitrary code. This is very, very powerful. The next thing that I wanted to show you is command aliases, which will simplify your build process. Instead of typing a large number of commands, you just type in once. So I'm going to go back to my build SBT, and I'm going to add a small section here, and I'm going to call this command aliases. And I'm going to use a function that's built into SBT. It's called add command alias. And add command alias will take two arguments. And the first one is the name of the command that you will want to use, the alias. And then the implementation, which is the equivalent of what you would have to write in SBT if you wanted to type them all yourself. For example, compile, semicolon, and then test, and then semicolon, and then assembly. Now, let me go write that, and then in my other project, I can start my SBT console. And with the new build SBT loaded, I can use the simple command to run all of these at once. So I can do CI, and then SBT will start compiling my code and then assembling my jars. One other thing that I wanted to show you here is cross-building between different Scala versions, because in the Scala world, this is an issue when you want to build, especially if you want to build your own library or your own tools. It's often useful to build that tool for a variety of Scala versions. For example, if you want to support Scala 2.12 and Scala 2.13, you might want to cross-build your Scala code for those values as well. So here under my build SBT, I can define values. For example, let's call this Scala 2.12 as 2.12.16 or something like that, and Scala 2.13 as 2.13.8, which is the value that I'm using here. And for this build Scala version, I'm going to use, instead of the string itself, I'm going to use the value, Scala 2.13, for example. Now, if you want to build your tool or your library for both Scala versions, you would have to specify a setting. And for example, if I want to define the setting here in my core subproject, I can have my, in settings here, I can have a comma here. And instead of having library dependencies, I'm also going to have a cross Scala versions. And I'm going to assign it just like I do for other settings as well. And I'm going to have a list for the strings of Scala versions that I might want to support. For example, Scala 2.12 and Scala 2.13. Now, if you want to compile your application or your module or your library for both Scala versions, let me go ahead and restart my SBT console. You would have to hit compile, and you have to hit compile with a plus because you want to compile your code against all the Scala versions that you want to support. So for example, if I hit compile, it will compile the entire project for Scala 2.13, which is the value that I specified at the top, which is this build Scala version. But if you want to build it against multiple Scala versions, you'd hit plus compile, which will run the same code against all the Scala versions. So notice that we have success for both Scala 2.13 and 2.12 as well. All right, folks, so this was part 3 and the last part of the SBT tutorial mini-series. If you liked it and found it valuable, click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn. I post fresh updates on upcoming material. And check out my home at Rock the JVM, where I have literally hundreds of hours of everything in the Scala ecosystem. So I hope you enjoyed it, and until next time, I'm Daniel, signing off.